In this video, I want to talk a little bit about base 10 blocks. You're going to see base 10 blocks used throughout your textbook, particularly in this chapter. Base 10 blocks are math manipulatives. Depending on your own experience in elementary school, where you went, when you went, what the philosophy of the school was, you as a student may have used these or you may not have. Similarly, depending on the philosophy of your education program, these may or may not be part of your methods courses. Hopefully, they are part of your methods courses. They were certainly part of mine when I would teach elementary math methods. And so I'm not going to spend a lot of time on them because if you're going to be an elementary teacher, you will take math methods, which is not this course. But I want to talk a little about them a little bit because they're very, very useful. So this is a diagram of what base 10 blocks look like. They have 4 different parts to every set. And sometimes the terminology used is different, and so what I use might not be terms you've used otherwise. So this big piece is in your textbook called a block. I've also heard it called a cube, but that's confusing because that's also, this small piece is also technically a cube. This represents 1,000 of these little pieces, and it truly is. Like if you were to be able to break one of these apart, which I wouldn't recommend, that's what you would see. Then a flat is 100 pieces, a long is 10, and a unit is 1. And so we see how these work exponentially. 1 long is 10 to the first, or just 10. 1 flat is 10 squared, or 10 times 10. And 1 block is 10 cubed, or 10 times 10 times 10, which is 1,000. We use base 10 blocks in various ways in elementary school. We particularly use them when we're teaching adding and subtracting, including adding and subtracting with regrouping, what you might have called borrowing in elementary school. But they're actually used beyond that. And so if you teach upper grades, I encourage you to consider how you could use these in upper grades. One thing you can do with them is work with them with decimals, where this is a whole number, this is a tenth, this is a hundredth, this is 1,000th. And so just as you use these as starting with the numbers 1,000, 100, 10, and 1 in, say, first grade, you could use these as 1, 1/10th, 100th, 1,000th in, say, 5th or 6th grade. So we often involve base 10 blocks with trading. So trade 1 flat, 17 longs, and 16 units to obtain the fewest blocks possible. So the first line here is what we start with. And then we see, 16 units, that's 1 long and 6 units. So we trade. Now we have 11 flats, 18 longs, and 6 units. But again, we can trade or regroup. 18 longs, that's the same as 1 flat and 8 longs. So after the second trade, we have 12 flats, 8 longs, and 6 units. And then we can trade the 12 flats to be 1 block and 2 flats. So our final answer becomes 1 block, 2 flats, 8 longs, and 6 units. That's the fewest number of pieces, which here happens to be 17, which probably isn't super important. So this is just trading here to learn about place value, right? Think about counting. When the biggest thing that kids struggle with when they count is when they get to tens or hundreds. And you'll hear this if you have a first grader or a kindergartner, depending on how much they've learned, count for you. It'll sound something like this. If they kind of know their numbers pretty well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And it happens again when we're a little older, a little later in the year, 97, 98, 99, 100. Those sort of break points because it involves different language, other things can be tricky for kids. Working a lot with base 10 blocks can help that. You're also going to work with base 10 blocks when we do addition and subtraction. Now, base 10 blocks are usually used as physical manipulatives, and they're probably best used that way. But there's also virtual versions. And so certainly the virtual versions might be useful in a case where we're worried about contamination, right? Or just in case of cost, because the virtual versions, although I'm sure there are apps you can download, there's also lots of free versions out there. I'm going to show you a couple of those. So what I hope you see on the screen, if this is recording right, is one such website. This is coolmathforkids.com. By using a website, I do not endorse it 100% or anything like that. I don't know what their pedagogy or philosophy is. Maybe they're crazy. I don't know. So the only bad thing with this website right away is that they don't include the largest piece. But they do include small pieces, and they're fairly easy to manipulate. I can add more in just by clicking and dragging, stuff like that. So this would be our number 3. I have 3 100s, so I have 300, 3 10s, and then 5 1s. So I have 335. And again, we could do something with this like we did, do a whole bunch of ones like that. That makes it a little bit easier. Wonder if I can copy and paste. Ooh, I can. I do like it when you can let me do that. So we can move them around, and we can use something like this for regrouping. Right? So I could say, oh, do I have more than 10 in this group? So let's count. I have 1, 2, 3, 4. I like that they snap together too. 5, 6, 7, 8, 9, 10, 11, 12, 13, that got hidden, 13, 14, 15, 16. I think I did this right. So by snapping together, we can actually even see here, this is a rod. So really, what I have here is one more rod. So I'm going to trade this in. So I'm going to just circle it. I'm going to hit the garbage can to delete it. Then I'm going to trade it in by drawing one more of these. So now I have 10, 20, 30, 40, and I can break these apart if that makes it easier for me to count. And 6. So I have 346. So a site like this, very beneficial. If you have a school that has a one-to-one initiative and kids all have tablets or something, I would assume that it's a way to get to sites like this on those tablets often, using obviously safe techniques. That could be beneficial. And this is just one of many. Here's another one. This is from Didax, which also sells physical manipulatives. And I like this one because it includes the full set, which includes the big cube. But other things, you can't really select in things. So different ones have strengths and weaknesses. But we could show, have a kid show me 1,204. And hopefully they would show us this. Right? This is what we would want them to see. We would not want to see this. Which is not 1,204. Let me try to erase that again. So there's all sorts of things you can do with base 10 blocks. Your textbook is going to ask you questions, and I include those questions in the homework assignments because base 10 blocks are really foundational tools, whether they are physical ones or whether they are virtual ones like these. And again, for this, I just searched interactive base 10 blocks, and there's 20 million plus results. They're not all unique. Some are better than others. Some textbooks publishers have them, so like some of you might in your classrooms use Glencoe. And so they have different virtual manipulatives. And again, some of these sites require Flash. Flash is probably being deprecated at some point. Some of them will use other tools instead of Flash. But so here's one that comes with a textbook. But again, they're free to use whether or not you use the textbook. So a little bit about base 10 blocks, just a brief introduction. I would encourage you strongly to play around with different sites like these. If you're ever in a school and you have the opportunity to actually work with the real thing, that's even better. They can be engaging for kids. Of course, if you overuse them, they're dull and boring for kids, just like anything else. But they can be a really good way of teaching throughout the elementary grades. Don't think the base 10 blocks are just for kindergarten, first grade. And even if you end up teaching, say, middle school, oftentimes if you pull out manipulatives for middle school students, they get super excited. So keep that in mind too.